few weeks back, Albert Einstein's imaginary elevator confirmed with remarkable accuracy. At that point, Albert Einstein's theory of relativity is shown to create gravitational lenses even form in other galaxies. Today, we discovered that a focal principle of relativity still holds even at gravitational extremes. This study generally says that gravity objects should fall the same way. It sounds clear, but the possibility that heavier objects should fall at an indistinguishable rate from lighter objects. The gravity accelerates heavier objects faster, but they're more massive, it's harder for them to accelerate. Galileo broadly exhibited the main by dropping lead wads of various waves off the Leaning Tower of Pisa and watching them hit the ground in the meantime. Apollo 15 space traveler David Scott reproduced it on the Moon, dropping the quill and a sledge. Both the objects hit the ground in the meantime. This time they used a pulsar and a white diminutive person. Approximately 4,200 light-years away in the group of stars lies a triple-star framework named PSRJ0337 plus 1715. It comprises of two white diminutive people, little stars only a small amount of the mass of our Sun, and a significantly littler, denser pulsar. The pulsar and one of the white smaller people circle each other intently, and the second white midget has a considerably greater circle around them. This ends up being the ideal research center for researchers to test exactly how far the equality standard goes. Einstein's general relativity accepts not only the standard proportionality rule, but rather a variant of it called the solid comparability rule. As indicated by relativity, gravity works by distorting space-time itself, and anything with mass would lose gravity. So sufficiently thick protests, for example, pulsars, aren't simply uninvolved travelers riding on space-time's bend, they're currently distorting it themselves, as well. Is Einstein's theory of relativity correct or wrong? By looking at PSRJ0337 plus 1715 for around 6 years, researchers can see whether that's the case. If Einstein and the solid equality rule are correct, at that point the inward pulsar white diminutive person combined ought to be steady, and the external white midget's gravity would influence them both the same. If Einstein's wrong, at that point the researchers would consider wobble to be the neutron's own gravity influences its circle around the white diminutive person. The group saw precisely what they'd hoped to check, whether the solid comparability standard is correct, no abnormalities or bizarreness, with a margin of error of just 30 meters. This latest space science rules out several alternative theories, including string theory. It also affirms that our understanding of gravity remains a sensible method to understand the universe. According to researchers, test of this rule has a long legacy. It is very remarkable that the reactions of various materials to gravity ought to be so comparative. In unique imagination, gravity isn't the power that follows up on these particles in some fabulously tweaked way, but essentially an impact of space-time geometry.